Hello and welcome to my today's talk about the topic, do commodities determine the EU emission allowances price? My name is Jan-Hendrik Meier. I'm professor of accounting at the University of Applied Sciences in Kiel in Germany, and I wrote this paper together with my research associate Norman Voss. For today's talk, I plan the following. I would like to introduce into the EU emission allowances and talk a little about the relevance of the topic. I would like to go briefly into prior research and research gap. I would like to show our hypothesis. I would like to go into sample and methodology. And I would like to show up some results and go into the discussion. The EU emission trading scheme was implemented in all 28 EU member states in 2005 as a cap and trade system, which means that the carbon emissions are capped and the allowances are traded. The aim of this system is to reduce the permitted CO2 emission quantities. The scheme consists of 4 phases. Phase number 1, between 2005 and 2007, implemented the trading scheme and sanctions for exceeding the ceilings. In phase number 2, between 2008 and 2012, the quantity of allowances that were distributed free of charge was reduced. In phase number 3, which is still ongoing, the national caps have been replaced by an EU-wide cap, and the emission allowances that are not distributed for free will be auctioned, and additional industrial sectors and emission gases are covered. In the future, in phase number 4, between 2021 and 2030, we will see further reductions of the ceilings and further strengthening of the market stability. Emission allowance from years prior to the previous year of the count trading are then to be expired. Why is research on EU emission trading schemes relevant? It is relevant to all emitters of CO2 in their decision, so for example to switch the energy source that they use, and of course for policymakers in climate protection. The literature on the dynamics and volatility of CO2 allowances has grown rapidly during the first and second phase of the EU emission trading scheme, but it has flattened significantly with the start of the third phase. What has been researched so far? On the supply side, the determinants of the CO2 emission allowance price, there has been research on price floor and price ceilings, emission caps below the usual emissions, national allocation plans and political influences, limitation of emission allowances and the distribution of new emission allowances, and predetermined price for additional allowances. But what is even more interesting is the demand side, and here explicitly weather conditions have been researched a lot, but also energy prices like oil, gas, coal and electricity are where we put our focus on. Further revelation of institutional information and economic activity has been analyzed. So the research gap now is to focus, or our study focuses on the influence of the price of Brent, which is crude oil, natural gas, coal and electricity. But in contrast to the existing literature, we consider the third period between 2013 to 2019. We expect substitutional effects between commodities as soon as the CO2 emission price is changing. Our sample consists of data from the Refinitiv icon, where we of course have the EU allowance price, the coal price as of Argus McCloskey's coal price index, the electricity price from the European Energy Exchange, the Brent price, and the gas price from the ICE exchange. And all the data is taken from phase 3 as of 2013 to 2019. While pre-processing the data, we differentiated the time series due to the ADF stationarity test, augmented Dickey-Fuller test. We applied a Granger Causality test, and of course we applied vector autoregression model. We see the vector autoregression model down here that we applied. So all the price time series are endogenous to all the others. Here's the result of the Granger Causality test, and we see significant influences of gas on allowances. Here we see coal on allowances, we see Brent on allowances. All the commodities that get burned, we see a positive influence on allowance prices, while electricity we do not see any significant influence. Further, we see a certain trade-off between gas and electricity, and we see a certain trade-off between gas and coal. Here are the descriptives of our data. Here we see the mean, median, and so on of the usual price series, and here we see the descriptives of the differentiated time series, and here we see the correlation matrix. We see highly significant correlation coefficients among all price time series here. Here we see the results of our vector autoregression model in terms of impulse response functions. Impulse response functions, including the confidence intervals, means we see a significant change of prices if the confidence interval excludes the zero line. So here, for example, we see the response of the emission price due to a 1 standard deviation shock in electricity. We see a certain down and up, but we do not see any significant result here. This is different as a response to a shock in gas. In gas, we see with a certain delay a positive shock on the price of allowances. The same we see with coal, and the same we see with Brent. In the cumulative numbers, this is a bit different. Here we do not see any significant result. So accordingly, those shocks are not long-lasting. And here's a part of our numbers, a part of our results. So this is the result of EU emission allowance prices. They react with a certain delay on themselves. So we see some kind of seasonal pattern in the data, and we see a certain delayed reaction on gas, on coal, and also on brand here. So, and they're all positive, so a positive shock in gas, a positive shock in coal, and a positive shock in brand will lead to a positive shock in allowance prices. Thank you for listening, and I would like now to open the discussion.